Welcome back once again, guys. Okay, so we've looked at our regression model, what it looks like, okay, and we looked at using a calculator doing that. And we said it's equation of the line of best fit. And we use our calculator to find the y-intercept and the gradient for the least square regression or the line of best fit. Okay, that's what we did. But now, what we're going to look at now is something called extrapolation and interpolation. How do we use the line of best fit to predict, okay? And do we really believe on the reliability of that? Can I say, yes, this is a good prediction. I'm confident about this. And what do we use to argue that, okay? So we'll look at interpolation and extrapolation. So inter, you can see, is in, within a data, and extra, it's outside. We're extrapolating outside the data. But let's look at what does that look like, okay? So we had Elena, okay? So we had Lena, 1 to 5. We had the chemistry marks there, all the chemistry, and we have the accounting marks, okay? And we use the data to find the least square line or the line of regression, which we did using our calculator, okay? Now the question is, for a chemistry mark of 30%, what mark does the least square line predict for accounting? Now, you get 30% for chemistry. What is the accounting mark? If you look at the data. Then the next question is, for a chemistry mark of 65%, okay, what does the least square line predict for accounting? If I get 30%, what is my accounting mark? If I get 65% for chemistry, what is my accounting mark? Okay, that's what we want to look at. But before we look at that, let's explore what is interpolation and extrapolation, okay? So, interpolation. A regression equation can only confidently be used to predict y that correspond to x value that are within the range of data value that is interpolation. Are we together? Okay, so if we predict within the given data, given data, we are interpolating. Okay, and that is what is important. With confidence, we can predict y. If the data we have is within the range, okay. Let's look at interpolation, again, using the line of best fit. What does it look like? So we have our dependent variables there, our independent there, okay, we can see that. We have our points, and the blue is our least square line or the line of best fit. So from there, that position, all the way to there, there was the data given to us. Are we together? That triangle. So if we predict, let's say I want to know, if my x is 6, I want to know what is y. I'm interpolating because 6 is within the range. What if I use 11? Yes, 11 I'm also interpolating because 11 is within the range of the data given. Why interpolation? What does that mean? Okay. It's reasonably safe to make prediction within the range of the data. So if we interpolate, the reliability of the prediction is really good. Okay? Are we all together if we interpolation? But there, outside, the range of a data is something else, which we'll talk about it, which is actually known as the extrapolation. So let's look at the extrapolation. It can be dangerous, okay, or not accurate. the forecast, the prediction, to extrapolate. To predict, that's what you're talking about, or forecast, from the graph, the value of y that corresponds to the value of x that lies beyond the range of the values in the data set. This is because, why? This is because we cannot be sure that the relationship between the two variables will continue to be true. Okay? If my range is from 5 to 15, I want to know what is happening at 20. Will the trend be the same? Will the same pattern be the same? We don't know. So we can't really rely on that prediction. Okay. But if it's within the range, we can really rely on that because we are interpolating. Are we all together? Okay. Let's look at interpolating. How does it look like graphically? Extrapolating. This is extrapolating. So the range for this is from there to there. This is a given range. That's the range. Now, beyond this 15, at that point, we are extrapolating. If I want to know what is happening at 16, at 17, at 18, I'm extrapolating. And it's really dangerous, especially on the reliability of our prediction or the forecast. Okay, we cannot really rely on that because we don't know what is happening beyond the range because we need more data. If we can collect more data and update our regression line, maybe we can. But if we do forecast or predict using extrapolating, we just have to say, is our answer is not reliable because we are extrapolating. Okay, we're good. So let's go back to our chemistry question, okay? So remember we're given 1 to 5 linear, we're given the chemistry marks and the accounting marks. So given chemistry and accounting, now we calculate our regression if you remember previously. I'll update that again. So now the question is, so let's look at the range. For this. The range, the minimum value is 45. The maximum is 86. If I predict any number between 45 to 86, I'm interpolating. But after 86, I'm extrapolating because the range is 45 to 86. Okay. Now, for a chemistry mark of 30%, what mark does the least square line predict about accounting? If I get 30% for chemistry, what is my accounting mark? What is my accounting mark? And is that reliable? Is 30% interpolating or extrapolating? Is 30 within a range? I don't think so. Because the minimum is 45 and the maximum is what? 86. I'll be extrapolating, I think. Okay. Now, for a chemistry mark of 65, what mark does the least square line predict for accounting? Okay. Let's look at that. So we do know that this is our least square line. We calculated previously is the equation of the line of best fit for chemistry, accounting, and where X is chemistry and Y is the accounting. So to predict this, what we need to do is where we see X, we substitute 30 minus 5.07 plus 1.17, 30. And what is this? I'm going to use my calculator. Okay. So I put this on my calculator, so it's minus 5 minus 5.0, not point, delete, 0.7 plus 1.17. Remember, this is the line we calculated using our calculator, and we're given now that chemistry is 30. What is my accounting? That's what I get, about 30. Let's go back, it's about 30.03, okay, percent. So if you get 30 for chemistry, the prediction, the forecast is about 30% for accounting. Is this reliable? No, not reliable at all, because we are extrapolating. We are extrapolating because of the given data. The minimum is 45, the maximum is 86. We're predicting outside the range, not a reliable prediction because of extrapolating. Okay, are we together? Because we don't know students performing around 30% for chemistry. We don't have the data to predict that. So it's okay with predicting 30, but not really accurate. We're not confident about that. Okay. But what about the 65? The 65%. Okay, similarly, let's see that. So 65%, let's predict and see what we get. So we just have to substitute, let me just update, minus 5.07 plus 1.1, delete, 1.117, bracket, where I see x, I have to put what? 65, because 65 is what? Is my chemistry. And y is my accounting. I want to know what I'll get for accounting. Which is what? Okay, which is, let's see what we get. We get 70. We get 70 point, that's 7 what? 8 or 9. Let's see that again. 798. Now, this is percent. So if you get 60 for chemistry, you will get about 70% for accounting. Okay? What do we say about this prediction? If you look at 65%, it's within the range. We are interpolating. I'll use the word. We are interpolating because we're interpolating that prediction. Confident about that prediction. That yes, if you do get 65% for chemistry, the chance of there's a good chance of you getting about 70% for accounting because we are interpolating. But the 30% we had, we are extrapolating. We don't trust that prediction. Okay, guys, fantastic. Hope this makes sense. So what we looked at, guys, our summary, we looked at the line of best fit, we looked at regression, we looked at interpolating and extrapolating. So the line of best fit is, we draw it from the scatter plot, but remember it must pass through the mean. And the linear regression, I use my calculator to calculate the A value and the B value. And be careful when you forecast or predict, use interpolation and extrapolation. I hope you enjoyed, guys, on this beautiful day. And we hope to see you soon. And I will encourage you to keep working hard. And good luck.